All right, so let's continue with our discussion on Physics 9702. So we'll be looking at the potential divider circuit, which is basically voltage division. Potential divider circuit, which is basically voltage division. So the question that comes to mind is this: when does resistor share voltage? When do resistors share voltage? When do resistors share voltage? When? The resistors basically share voltage when they are connected in series to a power supply. So you can write that down quickly. Resistors connected in series to a power supply forms a potential divider circuit. I'll go over that again. Resistors connected in series to a power supply forms a potential divider circuit, which means that let's consider a case in which this power supply, the power supply is having negligible internal resistance and it has EMF E. So the PD across R1 and the PD across R2 is a fraction of this EMF. So these resistors, they are sharing the EMF of the circuit. Is that okay? So we want to create an expression in which you can easily calculate the PD across this resistor when it's actually a potential division circuit in which the resistors are connected in series to a power supply. How do you calculate the PD across the separate resistor? The current supplied by this battery is I. That is the same current that is flowing through R1 and R2. So the PD across R1 is IR1. Then recall that I is the current of the battery, which will be given as the EMF of the battery over the combined resistance of the circuit. Is that okay? Because current is voltage over resistance. Since we are talking about the current produced by the battery, which is the current supplied to the circuit, to be the EMF of the battery, which is the EMF of the circuit over the total resistance of the circuit. That's what will give you the current of the what? Of the circuit. Is that okay? And after you have said that, we can substitute for this in this equation. Therefore, V1 will now become what? E over what? R1 plus R2 times what? R1. Therefore, the PD across R1, will be given as what? R1 over R1 plus what? R2 times what? E. Is that okay? Similarly, you can say that PD across R2, V2 is given as what? IR2. And we know that I is equal to E over what? R1 plus what? R2. Therefore, PD across R2, V2 becomes what? R2 over R1 plus what? R2 times what? E. Okay. So that is that. So, for example, consider find the PD across the 4 ohms resistor in the circuit shown below. Find the PD across the 4 ohm resistor in the circuit shown below. So we have 4 ohms, 6 ohms. This battery is 12 volts. So we want to find the PD in the 4 ohm resistor. The battery once again is having a negligible internal resistance. So I can say that the PD across the 4 ohm resistor will be given as R1 over R1 plus R2 times what? E. Therefore, V becomes what? R1 is 4 over 4 plus 6 times what? 12. 4 plus 6 is 10. 12 over 10 is 1.2. 1.2 times 4 will give us what? 4 points. Will give you 4.8 volts. That is this. So the PD across the 4 ohm resistor is 4.8 volts. The PD across the 6 ohm resistor, because these two resistors are sharing this voltage, if the PD across this one is 4.8 volts, then this one will now be what? 12 minus 4.8. If you have 12 minus 4.8, that will give you 7.2 volts potential division.